let's just say for the sake of argument there is this planet somewhere in the far reaches of the universe that managed to have life on it, survived, it's technologically advanced. Could these ETs be the explanation for the rUFOs that have yet to be explained?
No. I can think of 3 reasons. You got the distance problem, you have the velocity problem, and then you got the number problem. There's just way too many of these things.
Okay.
And in terms of distance, we're looking at hundreds of light years that these craft would have to travel. In the sense that we've already, as astronomers, been able to look at star systems that are close to planet Earth and recognize, based on the anthropic principle, they're non-candidates. Life can't exist there, so it's got to be beyond 155 light years from which these aliens would have to travel to. So that's a long ways through space. For example, take the fastest NASA spacecraft. We're looking at 112,000 years for that craft to travel that minimum distance of space.
But Hugh, this is just a technological problem. I mean, the world was large to people 50 years ago. Now the world's small. You can get around it in a day. Maybe 50 or 100 years from now, we'll have the technology to overcome these kind of problems in space travel, and therefore the ETs might have overcome it as well.
Well, the problem with transporting physical beings over interstellar space is you have to keep them alive, which means you must protect them from the cosmic radiation that exists in outer space, and you must protect them from the debris, the meteorites, the gas, and the dust that's out there. And the problem is the faster you go, what you want to do, you want to cut down that 112,000 years to something that's more manageable. But the faster you go, the greater the damage to your craft and the greater the damage to the beings on board. And it goes up with a square of the velocity. So if you double the velocity, the damage goes up 4 times. If you triple the velocity, it goes up 9 times. And so realistically, and this is something I deal with in the book, there's no way a spacecraft housing physical beings on board could travel at greater than 1/10 the velocity of light. Well, if we're talking traversing, say, 200 light years, that means 2,000 years for a one-way trip. So this has already put you beyond one lifespan to make the trip. And moreover, there's no guarantee that you would get those people there and back alive. You know, even getting to Mars is technologically difficult in terms of the hazards of interplanetary space.
Plus, what you're saying is a lot of people think of space as being space, empty, but it's not empty.
It's not empty.
Filled with dangerous things.
It's filled with dangerous things, and the faster you go, the greater the damage you're going to take, which means that your spaceship is going to have thick armor plate on it in order to withstand the meteoritic impacts. And you're going to need something like lead to protect the inhabitants from radiation. And the faster you go, the more of this stuff you need, and then suddenly you got the problem of moving this through interstellar space. You're going to need a lot more energy, hence a lot more fuel to move this through space.
And when you have more fuel, you have more weight, and you have larger size, and it complicates the other problems.
You need more fuel to move the fuel. So, the bottom line is, if you're talking a 200 light year trip, you're not going to make it with physical beings. No matter how much technology you have, no matter how much money you have, you're going beyond the limits of the laws of physics and the characteristics of the universe.
Now, Ken, Dr. Ross said there are 3 problems: the distance problem, the velocity problem, and then the numbers problem. How's the numbers problem work in here?
Yeah, you see the tremendous odds of even one craft traversing that kind of distance, but according to UFO phenomena, there are tens of thousands, possibly millions of crafts, and they're all slightly different from one another.
And they're all small.
They're all very small.
And if they're small, they're not going to make it.
So how do we, that raises even another question, what kind of economic issues are we dealing with that a civilization, a so-called civilization, could send that many crafts? There are multiple problems with this kind of interpretation.
Yeah, one physicist calculated that another planet would have to send out 10,000 spaceships per year to account for even the minimum number of residual UFOs.
And part of what you're talking about economics is there's got to be a factory somewhere that's building these things, and how do you maintain that? And these are some of the practical problems a lot of people don't ever consider.
If they're intelligent, they're going to use the assembly line process. They're not going to make different handmade craft every time they do it.
That's right.
And is there something like standard vehicles that you see with the same characteristics, or is there a duplicity, or rather, is there a large variety of different?
An argument can be made that virtually every UFO that is perceived or observed is different from the next one. And that raises serious problems.
So, Hugh, not only are you skeptical about the possibility that complex life exists anywhere in the universe for the reasons you gave, the problems of life starting by accident anywhere, and also the problem of the anthropic principle that everything's got to be just fine-tuned in the environment for that life to continue to exist. But even if it did, you're skeptical that ET could overcome the physical barriers that are obvious for any kind of extended space travel that could that would be necessary.
Well, something that NASA's even discovered: the farther away you go, the more economical it is to send machines rather than human beings. And if these extraterrestrials are intelligent, they're going to be able to figure that out. That you're much better off sending machines. I mean, you can send millions of machines for the price of sending just one spaceship.
Right.
And they're going to know that, and literally it goes up with a square. So if you're talking something beyond nearby planets, you're not going to send beings.
Well, Hugh, there are a lot of experts that agree with you here that there is a distance problem, although some have some unique solutions to that problem. In fact, we're going to read some excerpts from an interview with theoretical physicist Dr. Michio Kaku, from an interview on the abcnews.com website. Now, Dr. Kaku has written some books about the science of space travel, and he agrees with Dr. Ross that ET will have to abide by the same laws of physics that we do. In fact, here's what he says: alien intelligence will have to conform to the laws of physics as we know them. However, there are loopholes in the laws of physics that have to be investigated. Now, this loophole that Dr. Kaku suggests is more widely known as a wormhole. He says, quote, "This wormhole allows you to leap across vast distances within the twinkling of an eye without violating Einstein's theory of general relativity. However, the quantum theory, we still don't know whether or not the wormhole is stable once we take into account radiation effects. We don't know what lies on the other side of the wormhole. However, the theory, the mathematics, the computer programs, all seem to indicate that if you could harness what is called the Planck energy, 10 to the 19 billion electron volts, then you could open up a hole in space and time. You become masters of space and time." Close quote. Hugh, you're the astrophysicist. What do you think of this explanation? Can wormholes provide the solution to the distance problem?
No, there are three fundamental problems, but maybe I need to first describe what a wormhole is. It's a black hole singularity attached to another black hole singularity. So think of a highly massive compact object that forms this highly curved space-time configuration.
Kind of a funnel almost.
A funnel, right. And if one tip of that funnel from one black hole joins with the tip of the funnel from a second black hole, then you've got this wormhole where you can take a shortcut through space and time. But one of the problems is the idea that you can get the two funnels of two different black holes connecting one another to form a wormhole. That's highly improbable under the physics that we understand. The probability of getting two of these black hole singularities connecting is extremely improbable. The second problem is, even if they were to join together like that, it's highly unstable. The probability of them suddenly breaking apart is extremely high. It's only going to be there for the tiniest fraction of a second before it falls apart. So it means you've got to get through the black hole fast. But the most problematic problem of all is that nothing physical can travel through the wormhole. I mean, as Kaku points out, this is something that happens at the quantum level. And just for example, if we were to take your body and push it in through a wormhole, you're approaching this black hole, and the first thing you notice is that your body, 6 feet tall, gets stretched out to about 3 miles long, where all of the atoms in your body get strung out in a long line. And then as you approach the singularity, even the particles break down, so none of the particles would survive. And then even the smallest particle is not capable of traveling through the wormhole. So mathematically, wormholes are possible. Are wormholes possible? Yes, the mathematics of general relativity and quantum mechanics allows that possibility. The problem is the dimension of the wormhole is so incredibly tiny, not even the smallest quantum physical entity can travel down and through the wormhole.
So given our first two possibilities, that there's some unknown natural explanation or that this is ETs coming from another place, it seems like, given our first two explanations, which turn out to be natural explanations, either natural causes we don't know about or real natural ETs that are in some other part of the universe, it seems like physics has just slammed the door on those two possibilities.
Yeah, it seems interesting that once you begin to critique a naturalistic interpretation of life, you also have to add those criticisms to the extraterrestrial hypothesis. The extraterrestrial hypothesis depends upon a naturalistic understanding of life in the universe.
So as I understand it, Ken, the same body of evidence weighs against both hypotheses equally, so we have to really give some thought to the third hypothesis.
That's right, Greg.
So to sum up our point here, gentlemen, if these rUFOs are physical, then their ability to get here seems virtually impossible. In fact, given the mountain of parameters that you've just described here that are needed in order to have just one single planet in the universe capable of sustaining life anywhere is almost miraculous, if I could use that word here. But we do seem to have credible evidence still that something's going on. We still have our UFOs, that they exist, and that means if the first two explanations don't work, then maybe we have to look more closely at the third explanation. And this explanation has to somehow account for all of the data, the fact that these rUFOs are real, but they don't exhibit physical properties, but actually exhibit some of the non-physical properties that you discussed last time.
Non-physical cause with physical effects.
Right.
Non-physical reality.
This brings us at an important juncture in our conversation because given the three theories here, we've really amassed a tremendous amount of persuasive evidence that the first two theories are not adequate to account for our UFOs. That brings us to the threshold of a third theory that you propose to explain our UFOs, and that is the extra-dimensional hypothesis. What do you see as being the main strengths of this theory? Can you give us the strengths after you describe specifically what it is?
Well, the strengths are that there is this mountain of evidence that the cause is non-physical, and yet it's real. There are physical effects. And therefore it seems to speak of some kind of entity that's not confined or restrained by the 10 space-time dimensions of the universe. They have the capacity to invade our space-time dimensions, but they're not limited by our space-time dimensions. So in that sense, they're extra-dimensional entities. And that, of course, leads to the whole idea, do we have any physical evidence that that is even a realistic possibility? Mm-hmm. And this is where the astrophysics of the past 30 years, I think, is significant in challenging this naturalist paradigm that everything that is real is physical. You can appeal to the space-time theorems of general relativity, which simply state that if the theory of general relativity is a correct explanation of the dynamics of the universe, then the cause of the universe must bring the entire universe into existence, independent of matter, energy, and all the space-time dimensions associated with matter and energy.
Well, let's pause there for a moment because this is a very important point you're making, and I just want to revisit it just a little bit. Basically what you're saying is that science itself demonstrates that there's something outside of science. That is, something outside of nature.
There's something beyond physical reality. Something beyond nature.
Because some people are going to say, well, how can science discover the non-physical world? Science wasn't meant to do that. And you're saying even the foundational theorems of general relativity demonstrate that nature came from somewhere that wasn't nature.
Correct.
And so just in that we've got a very strong indication that something is outside of science, and this hypothesis draws upon that scientific understanding that there's more here than meets the eye in the naturalistic world.
And see, the skeptic is now forced into denying the theory of general relativity. And what's interesting about the past 2 years of physics research is that general relativity has now become the best proven, most exhaustively tested principle in all of physics. So given that we're forced to accept the reality of general relativity, we're also forced to accept the fact that the cause of the universe is a transcendent entity or a transcendent being.
Well,
therefore, non-physical reality must exist.
Right, right. So, I mean, this is a tremendous statement that you're making here when you think about it, because up until now a lot of people have simply thought that science by its very nature has limited our knowledge to the physical realm. And what you're saying is, in the case of UFOs, that knowledge of the physical realm disqualifies a fully physical explanation of the RUFOs. Well, and in fact, the science necessarily pushes us beyond that. We have scientific justification now for reaching into this extra-dimensional world for an explanation.
Well, science studies the universe, which is really the physical effect, but knowledge of the physical effect implies something about the cause of the physical effect. And we can now demonstrate that that causal agent transcends the physical realm. And earlier in this series we talked about the anthropic principle. And when you really get down to the nuts and bolts of the anthropic principle, the fine-tuning is so extreme that it cannot be attributed to any physical entity within the universe. It's too great. It speaks about a being more powerful than the universe itself to explain that huge level of design. And so the space-time theorems of general relativity, combined with this anthropic principle, the evidence that the universe has been exquisitely designed to make human life possible in this narrow window of time, both speak of the reality of something beyond the physics of the universe.